Hello, my name is Jeff Richley, and my project has been affectionately dubbed X302. I am working towards an autonomous drone platform that is capable of taking a classroom of students on a virtual field trip to areas that are not easily accessible. The idea of this came from a recent decline in field trips. This actually started even before the COVID-19 pandemic hit the world. The decline has actually been happening over the last decade. It's now estimated that only 10% of all teachers will plan and conduct a field trip in any given year. Now that many view online learning as a new normal, both students and teachers are learning that virtual experiences are actually quite effective. This project is a mashup of virtual reality and robotic tour guides. There has been work on robotic tour guides in museums since the early 2000s, but they have been limited to indoors and well-paved outdoor environments. This particular project is the early stages of creating a swarm of drones that are able to autonomously explore outdoor environments. Each member of the swarm is given areas to explore and is capable of finding points of interest utilizing computer vision. For the initial design of the proof of concept, I have a simulation that shows an overhead shot of an area to be explored by a single drone or a swarm. The area is divided into a grid that will be traversed in a methodical way. The current search method is called a Zamboni search, named after a vehicle used to resurface ice at a skating rink. The general idea of the search is to move in a straight line down one column and up the next until all boxes in the grid have been visited. The software side is divided into 4 distinct responsibilities. The blue represents the creation of the system via Simulation Factory. The coordination is represented by the yellow boxes where the GUI and simulation are shown. All planning is in the red area where the Zamboni mission resides. Other types of missions are planned, such as computer vision search and the like. The final green section represents the actual drone control portion. The drone communicates with the mission and other drones to get orders and notify completion. The drone controls the autopilot and gives it waypoints to fly to. In this scenario, the autopilot is a simulated autopilot, which is not currently controlling anything having to do with physics or a physical drone. It's actually passing information back to the GUI for a visual representation. In the final video of this milestone, you will see an actual physics simulation with a simulated drone flying. In this video, you can see 4 variations of the Zamboni path planning working. On the top left is a single drone searching the entire area by itself. The others are swarms of 4, 7, and 10 drones each. This system has been designed to control an arbitrary number of drones. For a field trip streaming video to a classroom of students, it would seem to be diminishing returns to have many drones flying at once, but the idea would be to show video feeds of drones that have found items of interest, such as when wildlife or interesting structures have been found. I have begun work on the actual flight stack that would run on board an actual drone. There are 4 major components that run in tandem, as can be seen in this diagram. The green boxes are the custom code I have created. The X302 box is essentially the system seen in the previous diagram. The computer vision will be the last phase of this project, but it's been stubbed out in order to verify the components all work together properly. The yellow box is the Robot Operating System, or ROS, an open source system for creating advanced robotics projects. This facilitates communication between all the components without having to directly tie them together, making everything small, discrete pieces of software running on the onboard computer. The red is another open source piece of software called ArduPilot and a companion communication stack called MavProxy. There are a number of implementations of ArduPilot that could be swapped out and used interchangeably. For example, this project is currently developed towards quadcopter drones using ArduCopter, but one could swap that out with ArduPlane and have it running on an airplane instead of a quadcopter. The final blue box is currently the gazebo simulator in order to easily test the system without crashing expensive hardware. It also cuts down on the development time significantly. Once the system's been proven to work reliably, this box will be replaced by a physical swarm of drones with very little code change. It'll primarily be a configuration change to tell ArduPilot how to communicate with the actual hardware. The final video shown here is the full flight stack working in concert. This demo only shows the drone taking off, turning, flying in a square, and landing, but these are all of the primary functions needed for the Zamboni search. In the upcoming weeks, this will be extended to fly multiple drones at the same time and fly over much larger areas.